Hello students! Once again, welcome to our lesson for this week, which is simplifying radical expression. The goal of our lesson is to simplify radical expressions. Before we simplify radical expression, let us practice writing the numbers into exponential form. Here, we will rewrite the numbers into the product of prime numbers. Do you know what is a prime number? Those are numbers whose factors are only 1 and itself. Let us have number 1, 32. This number have the factors of 2 times 2 times 2 times 2 times 2. In exponential form, it is written as 2 raised to 5 because if we count the number of 2's, we have 5. So that is 2 raised to 5. The number 2, we have 81. This number have the factors of 3 times 3 times 3 times 3. In exponential form, it is written as 3 raised to 4. Next, number 3, we have 100. This number have the factors of 5 times 5 times 2 times 2 because 5 times 5 is 25, then 25 times 2 is 50, then 50 times 2 is equal to 100. To write this in exponential form, it is equal to 5 raised to 2 times 2 raised to 2. Next, number 4, we have 72. This number have the factors of 2 times 2 times 2 times 3 times 3. In exponential form, it is equal to 2 raised to 3 times 3 raised to 2. Then number 5, we have 245. Its factors are 5 times 7 times 7. To write this in exponential form, it is equal to 5 times 7 raised to 2. Then number 6, we have 484. This number have the factors of 2 times 2 times 11 times 11. This in exponential form, it is equal to 2 raised to 2 times 11 raised to 2. In simplifying radical expressions, we are guided with the following law of radicals. Number 1, and the nth root of a raised to n, it is equal to a raised to n over n, or simply, it is equal to a. Then, number 2, the nth root of a raised to m, it is equal to a raised to m over n. Then, number 3, we have the nth root of a times the nth root of b, it is equal to the nth root of a times b. Next, number 4, we have the nth root of a divided by the nth root of b, it is equal to the nth root of a over b. Then last, we have the nth root of the mth root of a, it is equal to the product of the m times nth root of a. To continue, there are 3 ways to simplify radical expression. The first one is reducing the exponent of the radicand. This is about making the exponent less than from the index. To do this, we need to follow the rule, the nth root of a raised to m, which is equal to a raised to m over n. Examples are the square root of 49. 49 in exponential form is 7 raised to 2. So it is equal to the square root of 7 raised to 2. Following the rule, it is equal to 7 raised to 2 over 2. The value of 2 over 2 is already 1, so our answer is 7. Next, number 2. The cube root of x raised to 6. Following the rule, this will become x raised to 6 over 3. The value of 6 over 3 is 2, so our answer is x raised to 2. Number 3, the fourth root of 32. In exponential form, it is written as the fourth root of 2 raised to 5. As you notice, the exponent of 2, which is 5, when we divide this to the index, which is 4, will not give us the integral value. So, all we need to do is to separate the factors of 2 raised to 5 in such a way that the first factor has the exponent that can be divided to the index, which is 4. So, it is equal to the fourth root of 2 raised to 4 times 2. This time, the exponent of the first 2, which is 4, can be divided to the index. And its simplified form is already 2 because 4 divided by 4 is 1. So that is 2. And then the other 2 will remain inside the radical expression since the exponent is less than to the index. That is the fourth root of 2. So our final answer is 2, the fourth root of 2. Next, number 4, we have the fourth root of 81 y raised to 9. In exponential form, it is written as the fourth root of 3 raised to 4 y raised to 8 then times y. To simplify this, it is equal to 3 because the exponent of 3, which is 4, divided by the index is equal to 1. So that is already 3. Then the other one, y, as the exponent of 8 divided by the index, which is 4, will give us 2. Then that is y raised to 2. The other factors of y, which is y, will remain inside the radical expression. That is the fourth root of y. So our final answer is 3y squared, the fourth root of y. Lastly, we have the fifth root of 243 x raised to 20 y raised to 17. In exponential form, it is equal to the fifth root of 3 raised to 5 x raised to 20 y raised to 15 y raised to 2. To simplify this, it is equal to 3 because the exponent of 3, which is 5, divided by the index 5, will give us 1. So that is equivalent to 3. Then x as the exponent of 20 divided by the index, that is 4. So that is x raised to 4. Then y raised to 15 has the exponent of 15 divided by the index 5 will give us y raised to 3. Then the other y, which has the exponent of 2, will remain inside the radical expression. That is the fifth root of y raised to 2. The next process is reducing the order of the index if that is possible. Examples are the fourth root of 9. 9 in exponential form, that is 3 raised to 2. So it is written as the fourth root of 3 raised to 2. As you notice, the index, which is 4, and the exponent of 3, which is 2, are both divisible by 2, meaning we can simplify them. Following the rule, it is written as 3 raised to 2 over 4. 2 over 4 in lowest form, it is equal to 1 half. Therefore, it is equal to 3 raised to 1 half. In radical form, it is equal to the square root of 3. Next, we have the sixth root of 25x squared. 25 in exponential form is 5 raised to 2. So, it is equal to the sixth root of 5 raised to 2, x raised to 2. Following the rule, it is equal to 5 raised to 2 over 6, x raised to 2 over 6. 2 over 6 in lowest term, it is equal to 1/3. So it is equal to 5 raised to 1/3, x raised to 1/3. Since they have the same rational exponent, we can combine them as the cube root of 5x. Next, we have the cube root of the fourth root of 343. To simplify this, we need to multiply the indices, which is 3 and 4. So that is equal to the 12th root of 343. Then, this can be still written as the 12th root of 7 raised to 3 because the value of or the exponential form of 343, it is 7 raised to 3. Then, it is written as 7 raised to 3 over 12. 3 over 12 in lowest term, it is equal to 1/4. So that is 7 raised to 1/4. In radical form, that is equal to the fourth root of 7. Next, the fourth root of the square root of 16y raised to 4. The same with number 3, we need to multiply the indices, which is 4 and 2. So this will become the eighth root of 16y raised to 4. 16 in exponential form, that is 2 raised to 4. So it is equal to the eighth root of 2 raised to 4, y raised to 4. Then it is equal to 2 raised to 4 over 8, y raised to 4 over 8. 4 over 8, it is also equal to 1/2. Since they have the same, so 2y raised to 1/2, y raised to 1/2, we can combine them as the square root of 2y. The third and last process is rationalizing the denominator. It is the process of eliminating the fraction inside the radical expression. Examples are, number 1, the square root of 2 over 3. It is written as the square root of 2 over the square root of 3. As you notice, our target is to eliminate square root of 3 in the denominator. To eliminate it, we need the exponent of 3 be equal to 2, which is equal to your index, which is 2. We only have the exponent of 1, so we need another 3. So that is the multiplier is the square root of 3 over the square root of 3. Multiplying them, square root of 2 times square root of 3, it is equal to the square root of 6 over the square root of 3 squared. This time, as you notice, the exponent of 3 is already 2, which is equal to your index. Meaning to say, we can simplify this already. So our answer is the square root of 6 over 3. Number 2, the fourth root of 3 over x. This can be written as the fourth root of 3 over the fourth root of x. As you notice, our index is 4 and the exponent of x is only 1. So we need x raised to 3 as our multiplier. So our multiplier is the fourth root of x raised to 3 over the fourth root of x raised to 3. Then let us multiply the fourth root of 3 times the fourth root of x raised to 3. It is equal to the fourth root of 3 x raised to 3 over the fourth root of x raised to 4. As you notice, the exponent of x now is 4, which is equal to the index, meaning to say, we can eliminate now the radical expression. So that is equal to the fourth root of 3x raised to 3 over x. Number 3, 5 over the square root of 7 plus the square root of 3. This time, the denominator is a binomial radical expression. To simplify this, we need to get the conjugate of the square root of 7 plus the square root of 3. Its conjugate is actually the opposite of the operation, and that is the square root of 7 minus the square root of 3 over the square root of 7 minus the square root of 3. Then we need to multiply this conjugate to the numerator and denominator. it is equal to 5 times square root of 7, that is equal to 5 square root of 7. 5 times negative square root of 3, that is negative 5 square root of 3 over square root of 7 times square root of 7, it is equal to the square root of 7 squared. Then, square root of 3 times negative square root of 3 is equal to negative square root of 3 squared. Then, simplifying it again, it is equal to 5 square root of 7 minus 5 square root of 3 over square root of 7 squared is equal to 7 minus square root of 3 squared is 3. Finally, we have 5 square root of 7 minus 5 square root of 3 all over 4. To summarize our discussion, a radical expression is considered simplified if: number 1, the exponent of the radicand is less than the index of the radical expression. Next, the order of the index is the lowest possible order of the radical expression. Then last, there is no fraction inside the radical expression, or there is no radical sign in the denominator of the expression.